Hello, I'm Beana Puka from Molecular Biology and Genetics Department. For my Physics 101 experiment, I'm going to perform the Archimedes principle, and later by using this principle, I'm going to show how the density of the fluid and the volume of the object immersed affect the buoyant force. So the Archimedes principle states that when an object is fully or partially immersed in a fluid, then this object is going to experience an upward force which is equal in amount with the fluid displaced. So, the materials that we need for this experiment are an overflow can, as shown in here, another can which will be used to hold the amount of the fluid displaced, a measuring scale, a portable electronic scale, and an object. The fluid that I'm going to use to perform the experiment is water. First step, pour water into the overflow can and wait until the water stops dropping off. When it stops, we discard that water. Second step, we take our portable electronic scale, we turn it on, we place our object, and we take note of the value it shows before it is immersed in water, which is 200 grams for our object. We place the object into the water and we wait until the water stops dropping off. At the same time, we note the value it shows when it is immersed, which is 65 grams. After we measure the mass of the can itself, we subtract it from the mass with the displaced water and write all of our data in table 1. As we can see, as the Archimedes principle states, the loss in weight of the object or buoyant force is equal to the displaced water's weight. The little error might have occurred because of the overflow can which was made by me. Next, I will use this principle to find the buoyant forces for liquids with different densities, and will prove that the higher the density of the liquid is, the larger the buoyant force of the liquid will be. On the other hand, I will perform the Archimedes principle with objects of different volumes in the same liquid, water in this case, and prove that the larger the volume of the object immersed, the larger the buoyant force is.